name is Flavio. I read this recording on a workshop that I did at OVSCon 2022, easily deploying Kubernetes with OVN as CNI using Kind. To get to this workshop, try opening this link here, this bit.ly, which will take you right into this page. The way I would do it on this recording is just using Vagrant. So I'm just going to paste that here and then talk a little bit about what workshop was about. So you see there is Kubernetes and that is OVN. While there are a lot of folks who knows one versus the other, this workshop tries to bridge the two worlds a little bit. So for folks who know a lot about OVN, hopefully this workshop will give you an idea of how awesome OVN is and how it's used for Kubernetes using OVN as CNI. On the other hand, if you are a Kubernetes person but never really experimented with OVN as a CNI, hopefully this talk will give you some insights on OVN Kubernetes. So I'm deploying this as a VM here on this side, and then using this little application that I wrote called Reserves, which is also here on this page, on the same repository. Put in their email and then get a VM right away. However, now that we are outside the scope of the OVN Con workshop, you can just do it yourself. And let's say you don't have a Vagrant, but you do have a Fedora VM. There's a link to another page that just gives you the few steps that create a Vagrant user and then setup.sh, which I will show soon. And this is just another side note to pre-provision these VMs that folks jump into. I had a beefy bare metal and then I carved it up. The steps that I took for doing that preparation are also here in case you're curious or find yourself in a situation where you need to do something similar. Probably the most critical part of it is just installing libvirt and then Vagrant it. And once that's there, it was just a matter of coming in and then creating as many VMs I needed. Alright, so now back to here. The Vagrant file, as you'd expect, lives here right at the top level. And all it calls is setup.sh. Here they are, packages, installs Golang, which is the language used for the OVN CNI. Docker as the image builder, and Kind, which gives us a way of deploying Kubernetes where the containers are the nodes in the real world. Kube.sh just gives you an alias, so you type K instead of kubectl. And it's very importantly exports this variable called kubeconfig, which is what Kind generates once the cluster is up. So our kubectl just knows to look into this config file. And then at last we call OVN K8, which clones the main repository where OVN Kubernetes lives. That gives you the ability to plug into a Kubernetes cluster. Alright, so let's see what else is there. I think we are good. We are pretty much ready to move on to the next step, which is Kind. I will give it a minute here, let this Vagrant provisioning finish up, and then resume from there. Initial provisioning of the VM is up and we have all the pieces in place here inside the Vagrant VM, and I think we're ready to pretty much run. I'm gonna start a tmux session in here, and then I will start kind.sh, which is a shell script inside the OVN Kubernetes repository that you can call. Now while that's going, let me explain a little bit Kind. So Kind is a way of deploying Docker containers as Kubernetes nodes. So think of a world where Kubernetes cluster and then you have nodes in it. And these nodes, instead of being real beefy bare metal machines, they're actually Docker containers that are running. And then inside of them, just like in the real world, you have containerd and the managing pods and all the other pieces that Kubernetes would normally maintain. So that's why it's so powerful and allows you to pretty much have an all-in-one deployment that is actually equivalent to the real world. So that is Kind in a nutshell. Now that I'm launching it, it's gonna be deploying 3 nodes, and inside each node is going to be deploying the OVN CNI. So here is what the node looks like. I have pretty much a control node and a worker node. You can have multiple control nodes, and OVN Kubernetes is perfectly capable of operating under that, and then you would leverage Raft and everything else in the OVN databases to make it HA, highly available. But for the sake of this recording, I just have one control plane node and two worker nodes. And inside the control plane, you have the usual OVN northbound, southbound, north D, right, which you'd have on OVN Central in the OVN core world. And this piece here called OVN Kubernetes Master. OVN Kubernetes Master is the Golang piece which talks to the Kube API server, and then it takes from it whatever it needs to manage pods and services and whatever else Kubernetes needs in terms of networking. On the worker nodes, you also have OVN Kubernetes now operating in a node mode. It's the same binary, and it's just a matter of which flags you provide it, so it knows how to behave together with what you normally see on a worker node with OVN, the OVN controller, right, which is basically the OVN agent, and then the OVS and bridges and OVS, vSwitch D. In Kubernetes, what you also see in a worker node is a thing called kubelet. So think of yet another agent that Kubernetes relies on in order to control the containers that will be running in that node. And it's pretty much this picture here. So let me talk a little bit about CNI. Now, CNI is the piece that makes Kubernetes, depending on what technology you have behind for offering the networking interface. Dan Williams there's an awesome talk from Dan Williams. You can follow it on this link. What he expects is a bunch of well-defined call-ins, basically, and OVN Kubernetes has its own OVN K8 CNI overlay that I just clicked on it, so I just want to show you real quick inside OVN Kubernetes what it looks like. And it's very simple. You have add, check, and delete, and that is pretty much what the CNI plugin to OVN Kubernetes needs in order to know what we need to do. So for instance, let's say we are going to configure an interface, and let me open this link here real quick so you can see what it would take, right? So there's a CNI, and then you call, I want to configure an interface, and then if I kind of drill into here and then fall into all the pieces that would end up doing what we need to do. In our case, right, you would configure OVS, and this is inside OVN Kube node code, right? And then you'd see what you always see, like add port getting created, just to get a feel for how the CNI plays into OVN Kubernetes. Now this is the OVN Kube node piece, which is actually dealing with OVS, right? There's also the OVN piece where we're dealing with the OVN northbound database, and that is done from the controller side, which is not what I'm referring to here on the CNI piece. Okay, let me go over this so I can just solidify this a little bit better. So you have on the node, they have the kubelets, right? Cryo, the runtime managing container, and then the CNI. So when a pod gets created, and you'll see right here, what you have is when kubelet creates a pod, it has Cryo creating an IP namespace. Then the word namespace is very abused in this context, but in this case it's a Linux IP namespace, and OVN Kubernetes node will get the callback, create the OVS port, and then create a veth pair that taps the OVS port into that IP namespace. And on the master side, OVN Kube Master is actually also paying attention to pod creations, and then it's how he populates the OVN North B database using a library called libovsdb. Now libovsdb is a library written in Go that takes a schema and generates Golang native objects, and that is pretty much what OVN Kubernetes relies on. So we can talk directly to the OVSDB databases to configure OVN, basically creating a logical switch, port, anything that it needs managing for the OVN database northbound. And I think I will stop here and wait for the kind.sh to finish, and then we'll resume from there. At this point, the kind.sh script finished, and um, we have our deployment, our Kubernetes deployment up and running and ready to do things that we want. Now, let me spend a few minutes explaining some basics of Kubernetes for the folks who are not all familiar with it and how that's all packaged for OVN CNI. So as I talked earlier, we have the control node and the worker node, and while these pieces are very much accurate, um, I need to explain a little bit of how they actually get packaged and ran inside the Kubernetes cluster. Now in Kubernetes, there's this concept of a namespace, and it's not the Linux IP namespace that I was talking earlier. It's really a broader term where you can group a bunch of objects into almost like a very lightweight tenant kind of a way of thinking. So you can group objects, and pods are amongst them, where every pod belongs to a namespace, every service belongs to a namespace. And with that, when we are deploying OVN CNI, all the OVN pieces, they are inside a namespace, namely the OVN Kubernetes namespace, which I will show in a minute. And there's also another piece, and let me scroll here just so you can start getting an idea where I'm going with this. There's a concept of pods, right? And pods, while it translates one-to-one to an IP namespace, there can be multiple containers running in it, and all these containers share the same IP namespace in a namespace. And that's how it's run in the OVN Kubernetes, as I'm showing here. These are red things, OVN Kube DB, OVN Kube Master. Those are actually pods, and these highlighted OVN Northbound SB, Southbound of STB, those are containers running inside that pod. Now pods can be, while you can run pods directly to a namespace, they can also be created via a higher level objects, namely a deployment or daemon set. Deployments and daemon sets, and these in turn creates pods and manage pods. A daemon set is a way of deploying pods such that there's one per node, and a deployment is a different way of deploying pods in the way that you can have multiple replicas of it, and they are isolated from each other. They are self-contained. So you can have deployments where they are all versions of these pods. So that is that in a nutshell. There's also a thing called config maps, which we do use in our OVN Kubernetes, where we keep configuration. More specifically, when we launch the OVN Kube Master pod, it will look at these config maps to know some IP addresses, something that are very important for OVN Kubernetes to function, like the subnets that it belongs, type of things. And I'll show that later on when we're talking about Kubernetes services. Okay, so I think at this point, let me just cover one more piece about pods. Now, pods, while they can have their own IP namespace, and in that case be managed by the CNI, they can also be run in what we call a host network, and it's actually a parameter. And when we look at a pod, when you get a YAML, every object in Kubernetes can be easily seen as a YAML file. One of the attributes, if it has an attribute like this, host network true, that means that pod actually doesn't have an IP namespace. It shares the same namespace of the host where it's running. And for the sake of CNI, you will see that it makes sense, right? You want it to be part of the IP stack on the node where it's running, and that's why all the OVN pods that you see here are of the type host network, like that. And I will jump back on that in a second. And here they are, right? I can actually run this command right here, so you can see the same exact thing here. These are the OVN Kubernetes pods, and they're all running inside this namespace, and this is where they're running, the node where they're running. And as you can see, the worker ones have two pods, namely an OVS node and an OVN cube node on, and then the control plane has some more, and that is what you see here. Okay, now I think a really good tool to visualize this is there's a tool called K9s, and I'm gonna actually go ahead and install it and run it here, and I think that would help visualizing things a little better too. So let's just give it a second to download and run it. You see namespaces on the left side, the pods, and the nodes what they're running. Now let's talk about nodes. So as you can see from the Kubernetes perspective, there are 3 nodes, and these are it right here, right? And if I let me break this window up a little bit. If I'm back to here and I do a PS of Docker or Podman in this case, actually I think Podman is just a native for Docker in this machine. You see there are 3 containers, right? And they map one-to-one to what Kubernetes sees as nodes. And let me scroll up here. It's just getting ahead of myself a little bit. These nodes, they have the IP address associated with them right here, right? Internal IP. And these are the IP address that the node uses to talk to the outside. So if a node wants to talk to another node, this is the network that it talks about. And if you look at the OVN Kubernetes pods, do you see the IP addresses in them? They are, let me sort this by node. So they are the IP addresses of the nodes, and those are pretty much a good way to tell that these are host networked pods. They don't have an IP address different than the node itself. Another tool is OVSDB monitoring, and this tool, it's something that Adrian and I worked on a little while ago, and now this gives you a perspective of things from the OVN side of things, right? So while you have a pod running on a node, you need a logical switch port, everything that kind of goes associated with it on the other side of the fence. And this is a great tool for looking at that. Okay, so while that's starting, I'm gonna jump one more place here, and that is I wanted to show you really quickly how easy it is to change the code, then recompile, and then have it running again. And how after compile you create an image, and then from that image you push it and you can pretty much restart the pod. So yeah, it's this section right here. So just really quickly, what I'm gonna do is I'm just gonna create a patch file here that adds a line to that code that I showed you earlier, where we're creating the OVS port in the OVN cube node, and then I'm gonna patch it, and then here's the difference, right? And then I'm gonna just do this command, and this command is what will be pretty much rebuilding and changing things. So let me make this a little big and show you the lines. So it's doing a make, right, of the Go controller in Go, right? And then once it's done, it's gonna copy that binary into this particular directory and then rebuild the image that it turns into what the pod uses. And while it's doing that, I will show you that. So you see how they have OVN cube node here on the K9's screen. If I click on this, so these are the containers running inside that pod, right? And if I want to look at in particular how those containers, what images those containers use, you can see right here, right? Localhost daemon set, it says right there the image. If I want to do it a little differently, I can do, I think, the Y for YAML, and then I can look for the image here, and there it is. So basically the commands below are doing nothing but uh, getting a fresh version of that image and then loading into the Kubernetes cluster, and then it's going to go ahead and kill those pods. Now, because these pods, like I was saying, they're deployed as a daemon set, right? So let me quickly show you that. So there's a daemon set called OVS cube node, and you see how it has a number of desired, current, and ready. So right now we're about to delete them, right? And you see that they all went to nothing. But because the daemon set is there and he knows that I need 3, now it's just gonna pretty much restart them using the new image that we just built with a little change in the code. So now I'm gonna go inside the control plane container, and then from in there take a look at what is running as far as cryo is concerned. And then my pods up there are running and happy again, so that's good. Now if I were to jump in here, so now I'm inside the OVN control plane container, and in the real world that means I'll be inside the node, right, control plane node. And then in here, these are just some configuration files for how the CNI works, and you can just do that on your own later. But what is interesting here, if I do this PS right here, I will see the actual things running inside that node, and you can tell this is the control plane. So there's an awful more things running here, but in a sense you can tell the pods and then the containers. So as you can see, there are 3 containers running inside this pod, and that's why you see this line 3 times, and then it goes from there. If I do something just like, wait, let's do that real quick so you can compare and see the difference. Let's say I'll go now inside the worker, and then I do the cryo PS, and you see a lot fewer containers running, which is nice. And you can see what they are, right? The metrics exporter, I didn't talk about that, but it's just that is collecting a whole bunch of metrics, OVN controller proper, and the OVS. So this one, let's talk about OVS daemons container a little bit. So this is where vSwitch D is running, and that's, so if I wanted to see the OVS bridges or something of that matter on this node, this is the container that will have it all. It's one container and one pod, so it's just one container pod. Let's explore that a little bit. So if in fact I'm gonna jump in here, and I'm gonna go inside the OVS pods and OVN Kubernetes pods. So now if I jump into the OVS node, right, which like you saw, there's only one container, and then I can start a shell RI on it here, and then I can do things like this. I can do OVS Gato show, and then you'd see the bridge and the ports in there. So now I'm inside the IP namespace of the container that represents the OVN control plane node. And then in here I can see a bunch of ports that are interesting, and I'll show you a picture. Maybe a picture would do a service here. There are bridges here, namely the breadth 0 and the BR-int, right? And then there's a port called OVN K8 MP0, which is the OVS port for management access. We have a bridge called breadth 0, which is, if you're familiar with OpenStack, is the BREX bridge. And this bridge goes north and south of the node. And then BR-int, which is primarily a bridge controlled by OVN controller, and where we have all these ports, namely the Geneve ports that we get from node to node through Geneve, and then the management port that I was talking earlier, the OVN K8 MP0. Okay, this picture is probably very useful here. So yeah, this is where the breadth 0 bridge sits, and then BR-int you have the other ports, this port here, OVN K8 and P0. Every node in OVN Kubernetes has its own gateway router, and it has two logical switches, the EXT, and then named after the node, and then one that is named after the node itself. And those this logical switch, this OVN logical switch, is where all the pods get an IP address when they get created. They all get attached to this logical switch, and every logical switch per node has a subnet already pre-allocated for it. So when a node gets created, the address that it's given to the pod will be out of that range. And that is this piece. Now let me jump. Sorry if this is too much jumping here. To talk about a little bit about this. The Breath Zero bridge is actually managed by the OVN Kubernetes node, and it has a bunch of open flow rules in it. And namely, these are rules that allows us make smart decisions about when to do netting of the packets going north or south, and when we want the packets to go to BRINT through the patch port, or we actually want the node to process them. So to have those smarts and knowing how to handle, because these are host network pods, right, running, we want some packets to go to BRINT, and some packets to be netted, and some packets to actually be handled by the node itself. And those all live inside here as the open flow rules that you can see here. I think I can just show them right here since I'm here. Yeah, so these are it right there. Okay, and then the code that manages that, actually I think I have a link to it here in case you're curious, and you can get a pretty good feel on what they are about. Okay, and then here's the bridge, and I think at this point we are ready to do some fun experiments. And I'll stop the recording here to take a little coffee break and then come back to it. Folks, so let's resume our adventure. Start off by talking a little bit about some important metadata data here. Like I was saying earlier, every node has an address, gets it to the outside network, and you can actually see what they are from these commands here. When you describe a node, and you pretty much get annotations, and in it a whole bunch of information, including its IPv4 in case there's an IPv6 address in there as well. So I'll do that here just so you can try it. And get back here. Yeah, so as you see, my OVN, my control plane has this address, the 03, and worker has 02, and worker 2 has 04 in this particular deployment. As I was talking earlier as well, every node is given a range of addresses, and these addresses are pretty much what dictates what IP addresses its pods will contain. So in a control plane node, I can see that all the pods will come out of this subnet. Namely, OVN worker will come out with an address out of this range, and if I create a pod and the pod comes out of this node, we know it's going to be something 10.254.2. something, right? Now, how we get these? Now, these come out of the config map that I was talking earlier. So let me, and you would see it right here. So this NetCiter, you see how every node in the previous command was given a 1054/24? Well, that's broken out of this subnet into every node. Later on, I will talk about services, and then this is the pool of addresses where the services is going to come out of as well, and it's also part of the Kubernetes configuration. For our next part, I will start a pod, and I'm gonna override and force it to be running out of the OVN worker 2. And because it's gonna be OVN worker 2, we kind of know already it's what address it's gonna have, right? It's gonna be a 10.254.2 dot something. Okay, now here I didn't run this yet, but if I start OVSDB-mon, I can actually see everything that happens on the OVN side of things. On the north, I'm actually monitoring the northbound database here, and I wanted to see a logical switch names. Let's see, these are the logical switch that are configured in the OVN northbound, and this should be pretty familiar to you, right? Is every node has two, right? One and one named after itself, and one that starts with ext, and those are the two logical switches that we have here that connect it to the outside world. One that connects to breadth 0 through this gateway router, and one that is its own one. There's another one called join, and this one connects to a distributed router called OVN cluster router, which is how you get east-west traffic Kubernetes deployment. Okay, so now that we have that, I'm just gonna be monitoring this, and then I'm gonna go ahead here and create a pod right here. If I just do a click on 2, these are the default namespace, which has nothing running yet. To start the pod, and if we look at the namespace, okay, you see a bunch of things happen here. So we have our BusyBox running on the default namespace, and if I went here and I did a scroll back, you can see the things that happened. We have a change to a logical switch where, let me make this a little bigger. So we create a logical switch port for the pod, and it's the address of it. You can see right here. We added to an address set, which is actually an address set that represents the default namespace. Since it's the only pod there, we just see one here. That logical switch port that we just created, it gets added to a logical switch, and every logical switch, there's one per node, is named after the node where it's on. And I think besides that, there's the port comes up, and that is it as far as OVN databases. While we have this running, let me jump into the node and then do a little poking in there so you can see from inside here. And I do a cryo ps. We're gonna see our bbox container running, right? And then there's a pod ID, which is very important in how to map to what pod it came from. So we have a bunch of namespaces here on worker 2, and we're trying to guess which one is for our bbox, right, that we just created. So a good way to do that is actually to look at the OVN cube nodes log for that. So for that, I'm just gonna jump in here and then do a okay. So if I do k logs grep for CNI dash CNI FZ08, so yeah, this one right here. And if everything is right, this is the MAC address, and this is the IP address it's given, right? So let's try that. I'm gonna do do this, okay, and then its name, and do an IPA, and yeah, that looks right. And I think we found our bbox namespace, IP namespace. Okay, so basically what I was showing is a way to correlate the IP namespace down in worker node all the way up to the pod. And then we can go up and look at the logical switch ports, right? So for that, I'm just gonna jump into the DB pods for OVN Kubernetes, and then let's locate our DB, yeah, right here, and then I'm gonna shell into it, and I want the northbound one. And then let's take a look at the logical switch OVN worker 2. And you see there's a bunch of ports in there. Every pod has a well-known name and in the namespace. So if you combine the namespace and the name of the pod, you can actually find the port by its name, which is I think what I'm doing here in this command. So yeah, exactly what I'm doing here in this command. So this is the logical switch port that should be part of this logical switch. And yeah, sure enough, we have the address in there. All right. Okay, one more thing. Let's take a look at OVS proper. Let's see if we can find the OF port for this pod, right? So for that, I'm just gonna jump into a different pod. In this case, the OVS node on OVN worker 2, right here. And then from here, we know it's interface ID, right? Because it has the name in there. And then from there, we can look at it from the external IDs. So we can do that. And I think this is our guy here. Yeah, 92.9. If you remember, we made the change. So when we create a port, we add this external ID. And sure enough, there it is, right? So we know it's there. And it's OF port 11. All right. What else would be interesting to see here? I guess another one less place that'd be kind of fun to look at would be the controller, right? We can look at the logs, the OVN controller, and see claiming that port on this node. So let's do that. So I'm just gonna go back here, and so where we controller be inside the OVN cube node pod, right? And there it is. And then from here, I can look at the logs. Let's look at all the logs it had. Yeah, sure enough, there it is, claiming that port when we created it. All right. Okay. Let me take one more pause here, and then we jump into the last piece that I want to talk about for this recording, which is the Kubernetes service, a node port. So imagine in the underlay, this network here, you wanted to access a pod. And how you do that? Well, you do that by exposing it through a port on the node, where the pod is living. And how do you do that? Well, not only that, Kubernetes allows you to access that pod from any of the nodes. So when you do a node port service in Kubernetes, a TCP port in this case, that if you hit any of the nodes with it, you will know how to internally map and find the pod where it's running, or multiple pods, because it's actually a load balancer that gets created. So in order to accomplish that, we need a load balancer that can take that external IP and then map into this service IP. That's what we have here. If I were to do this command, right, and you can see the output there already, but I'll just do it in here just for sake of completeness. You see that there is a config map called OVN config, and in it you have this service CIDR parameter. Now the service CIDR parameter actually comes from a configuration which is out here, flag called service cluster IP range, and that is the address that will be given internal IP. So the command to do that is actually this. You basically expose, I mean, you can do various ways, but this basically creates a service. And then because I'm exposing the pod P box, it knows that that service is going to use a selector that that pod is using. And it can be multiple. In this case, it's only one, but it would be a load balancer with potentially many endpoints. And I'm telling it that the pod is going to be expecting packets on this port 8080, when I'm exposing it. Now that's not the port that gets exposed at the node level. That is this other port here, which is on the 30,000 range. There's some pretty good documentation on how this works, and you can take a look at that. I think it's, yeah, document. There's a link to it right here. Just need to take a look at that. Now, for the fun of it, inside our pod, let's start a little netcat command. If some packet comes into that port 8080, you actually get an answer. From the outside in, I can create a pod container on this network here. Uh, when Podman deploys this cluster network list, I'll see a bunch of networks, and the kind network is the one that I want to be running on. And we can take a look at what IP address. So I can see that I have an address in the 10.18 network, which is pretty much all I care about at this point. Here. Okay, and there's a whole bunch of things happen. You can see on the second window down, and I can do a describe service that I just created. This is the address, the cluster IP address it was given in the 1096 network, and this is the port that the nodes are expecting a packet to arrive on. So if I send a packet to this port on any node, I should get an answer for our little guy. So let's try that here. Port, hopefully we get an answer. Yeah, there it is. There's our little guy, and it got an answer. Now let's look at OVN. So when we created that service, right, a whole bunch of things happened. Let me scroll back a little bit. Namely, we created a load balancer for every node, and then we attached that load balancer to gateway router. So yeah, these are the load balancers, and you see one on every node, and you can kind of see where it is right here. So this is for worker 2, this is for worker, and then we see that load balancer being added to the local switches on every node, right? And then we also have it added to the logical router. And then we add the endpoints to it. So this is the VIP, right? 31448, and then the port. So I hope 31448 is the port that I used for my little example. Let's make sure. Okay, so there's a lot more that I'm not going to touch on today on this recording, and then I have it listed here. Oh, and so here's the output of basically what I was showing in there. You can do some other experiments, namely you can create a daemon service and then connect to it to see it pod to pod using OVN Kube Trace. The rebuild we actually covered. There are features called like egress IP, network policy, and many others that all have plumbing into OVN Kubernetes that makes OVN support whatever Kubernetes needs it to do. So yeah, I think this is enough for now. Otherwise, I'll just put you to sleep if I haven't already. But go through here and then don't be shy to reach out, and hopefully this will be useful to you as you get your adventures into OVN and OVN Kubernetes. Thank you for your time. Bye bye.